Maybe we'll do the first part of 6.1 and take a little break, and then we'll come back and do the other part of 6.1. So 6.1 is all about finding a common factor and then taking that common factor out of a polynomial. So dividing it out, just like that problem 75 from 5.5 just did. The only difference is going to be you're going to figure out what to take out. Okay, so the first problems in 6.1 are exactly that. So this section is mostly about the greatest common factor, but it's also about factoring by grouping. Okay, and these are two of really maybe 4 methods that we're going to use to factor. So these are crucial to learn. Okay, first thing is, what is the greatest common factor? And from now on, we're just going to call it GCF. Okay? Okay, so simply it's the factors that they have in common. So to start, it's just going to be find the GCF between 2 numbers. Then find the GCF between 2 terms with numbers and variables. If they don't have anything in common, like 2 and 3, they have no factors in common because they're both prime. So the biggest thing that we could divide into both of them evenly or nicely would be 1. So the GCF is always 1 or a greater number. Okay, that's not true, it can be negative, kind of. Okay, okay, so some examples. Find the GCF. There's no number next to these because they're not book problems, but 4 and 6, right? So the way you would do this is you would first write the prime factorization. I'm going to show you the rigorous method because we always need to learn that first so that we get the why, and then later it'll become second nature and you won't actually take these steps to write it out. But at first I would strongly encourage it. So we factor this into 2 times 2 and 2 times 3. So this one is 2 times 2 and this one is 2 times 3. So what are all of the factors they have in common? 2. And that's part of the magic, the beauty of numbers, which I think is so amazing, is you can take any number and exactly break it down into its prime parts. We call it the prime factorization, and we did it in chapter 1. You can write any number, like 372, and say exactly what it's made out of. These are the primes. There's one way to write this number in terms of its component parts. It's kind of like chemistry in that way, although I really don't like chemistry, but it's kind of like chemistry in that you can say this molecule, this material is exactly made of these atoms put together in this exact way. And I love that. Numbers, it's even more beautiful, simpler, in that it's made of these primes. 6 is exactly 2 times 3. There's nothing else hidden inside of it. That's it. That's 6. That's its full nature revealed. And I think that's pretty beautiful. So now, what about another one? Something like, 27 and 48. Okay. First, let's write. This is 3 times 9. That's 3 times 3, so there are my primes. Here's 2 times 24, 2 times 12, 2 times 6, 2 times 3. So this is 2 times 2 times 2 times 2 times 3. And this is 3 times 3 times 3. So what do they have in common? Just a 3. As soon as you circle that 3, there's nothing else they got in common. 3, 3, 2, 2, 2, 2, 2, nothing else. So the GCF is 3. Whoops. So really quickly, how to find the GCF? Numbers factor each into primes So if you want to do the numbers, which is really the only kind of, you could call it hard part, is you just factor it into its prime numbers and just give the ones they have in common, right? All multiplied together into one mushy clump. Right? For variables, it's even easier. Okay, so really easy, here's an example. What's the GCF of x squared and x to the 5th? Plus more than x, because think about it, this is x times x. This is x times x times x times x times x. What do they have in common?
X squared?
Yeah, right? This one has 2 x's, this one has 2 x's, and then this one's out of stuff. You're at a limit, there's nothing more. So the GCF here is x squared. Okay, so whenever you're dealing with two variables, it's really easy to find the GCF. As long as the variable is in both terms, it's just the lower exponent. If you have an x to the 17th and an x to the 24th, the GCF is x to the 17th, right? That's it. There's not a lot of logic going, it's just, is there a y in every term? Okay, what power is my GCF? Y to the, and you just look for the smallest power in any term. And if there's no y, then there's no y in your GCF because it's not a common factor because it's not in every term. Right, so really straightforward variable. So let's just do a bunch of examples of this.
What's the LCM again?
Least common multiple, so yeah, just, that's a good sidebar note. So, just as a little sidebar, this wasn't part of the notes, but LCM versus GCF. So LCM is least common, yeah, multiple, meaning, let's take like, let's take 20 and 12. 20 and 12, we need to say, okay, so this is 2 times 2 times 5, and this is 2 times 2 times 3. We need a number that contains all of these, like wholly contains this, and wholly completely contains this.
4.
So we would need we would need this whole thing, right? So we would have to have a 2, and a 5. And what else are we missing still? And we're missing a 3. We already have 2 2s, but we don't have a 3. So the least, the smallest thing that completely contains this number and completely contains this number is this for 60. Because 20 goes into 60, it's divided, it's 3, and then divide 12 into 60 and you get 5, And so this contains both these numbers, and it's the exact smallest, least number that contains both. The greatest common factor is, what is the biggest thing that they have in common? So yeah, we already wrote that. So 20 and 12, it's 2 times 2 times 5, and this is 2 times 2 times 3. And so the biggest thing they have in common
2,
is 2 times 2,
2 times.
or 4. Right? Because 4 is the biggest thing that we could fit inside
Okay.
of both. Right? So it's a difference of what do they both fit into, or what fits into both. Alright, so that was a side question. But yeah, so just a couple examples, and then yeah, maybe that'll be a good time for a break. Okay, so let's see, so 2 is find the GCF, 5 and 15x. 4 is 20x squared and 15x. Usually, I don't do so many examples right at the beginning, because I'm kind of like, oh yeah, you guys got this down. However, the GCF is so crucially important and new that I want to do a bunch of examples. 2, 4, 6, 8. Who would be the pushy GCF? Okay. So 8 is, now we got 3 on 8. Ha. Time for my sleep. Sleep deprived. Stayed up till like past midnight grading, and I was like up at 5:45. What am I doing? My kids slept perfectly too.
I was up to 2 watching South Park.
Yeah, well, that's just bad decisions. Alright, so 2, not that it's a bad show, although I don't watch it. Okay,
5.
so yeah, for this one, this is 3 times 5 times x, but this is only 5. So the GCF, the only thing they have in common is,
Is 5.
yeah. Okay, over here, this is 2 times 2 times 5 times x times x. This is 3 times 5 times x.
5x.
Yeah, they both have a 5x.
And both have an X.
And we're sure this one doesn't have a 3 and there's nothing else. So the GCF is 5x. And again, this starts to become second nature, but I would write it out to start. Okay, so this one is -1 times 3 times x, x, x. This is 2 times 3 times x, x, x. So what's the common factor here?
3x to the third.
Exactly, the 3 is in common and 3 of the x's. And you're sure there's no more, because this one only is a 2, it's not over here. So 3x to the third. And last one, now we need to do it with 3 terms. So 2 times 5 times y. 2 times 2 times 5 times y, and -1 times 5 times y.
5 what?
So they all have a 5 in common, and they all have a y in common. And we know there's nothing else, because the only other thing this has is a -1, which doesn't show up in the rest. So the GCF is,
So there's better than just write it out and just see it that way.
I think so, at least to start until it becomes second nature, and then skipping a step or two might become easier. So what I'm gonna just write out is start the next part, and then we'll take a little break. The whole reason we do this is to factor out the GCF. Most importantly, this is always the first step when factoring a polynomial. And I mean, you will hear me say this over and over. You guys will say, oh, can you do problem 23? I'll say, sure, what's the first step? And everybody will say in unison, factor out the GCF, and stand on a desk and yes, that's true. So every single time we factor a polynomial, first thing we do is factor out GCF, or at least check. Sometimes there is no common factor, the common factor is 1, and so we go, okay, we don't need that step. But absolutely you need to check. The reason is, if you have a problem like this, okay, that's gonna be really easy for you to factor in a day or two. Okay, you'll say, oh, that, I got no troubles with that. However, on a test, I would very often give it to you like this. Whoops. Okay, and so the first step would say, oh, there's this extra what in every term? Even more than x.
Squared.
Yeah, there's this extra x squared in every single term. Totally unnecessary, uncalled for. Let's just pull that x squared out. This is what we're going to talk about now. Okay? And then you would see, oh yeah, hidden behind all that extra junk, this was what was underneath. So the first step is to take out that x squared from each. And what we're essentially doing is do the exact inverse of distributing. Okay? And that's going to be your first step. If you see this problem and start doing some wonky magic, right, that's not going to come out right. You can't factor this with any of our normal methods until after you take that GCF out. And then this will be an easy problem for you in a couple of days. Okay? But a problem I see on tests is people don't take out the GCF and then they just start hitting this with a hammer and weird things come out. Okay? If you see that first step on every problem on the entire test, it's in about a week and a half, is I'm going to take out the GCF and then whoa, that looks way easier now. Okay, and you can see things that otherwise were hidden behind this curtain before. Okay, so every time I say factor, which will be 2/3 of your upcoming test will be factoring. Okay, you always do this first. Okay. Okay, so just to show you, here's an example. Let's go 3x times, and just make something up, let's say x squared plus 2x minus 7. Okay, so you guys already know how to distribute this in. Okay, I would distribute this in and I would get 3x times the first thing.
3x
Yeah,
plus 6x squared.
Yeah.
Minus 21x.
minus 21x. Okay? Going from here to here, we call this distributing. Going from here to here, we call this, whoops, factoring out the GCF. Okay, that's what we're going to practice right now, which is first establishing what do these have in common, just like those other problems. So what do all those terms have in common? You would say, okay, well they all have a 3, they all have an x, so the biggest thing I can take out is a 3x, and then you will factor out that 3x, and you'll be left over with this times that 3x. Okay? So that's a good spot to take a break. Nice big picture. When we get back, I'll break down the steps and the details. Alright. Alright, so picking up where we left off. So factoring out the GCF, it's going to be the first step in this process. Really what it's talking about is exactly what we were doing in 5.5. The only new part is you need to figure out what the GCF is first, then we're going to divide it out. Okay, so let's do an example together. So here's an example. Number 14. Instructions are factor out the GCF. Problem 14 is 9x plus 9. Okay? What's the GCF?
9x.
Yeah. GCF wouldn't be 9x in this case because this one
Oh,
doesn't
it's
have
9.
just 9, right? Okay, so
So-
after we find the GCF,
That will be 9 times x plus 1.
yeah, well, let's write it out step by step. So what we're going to do is we're going to take out the GCF out front. And then we're going to take this 9x plus 9, and since we're factoring out, instead of multiplying in this 3x, we're gonna divide the 3x out. It's still there, but we're taking it out of the polynomial and putting it separately out front. So we're gonna divide the 9 out and then write it out front. Because obviously, if we multiply 9 times this over 9, those two 9's would cancel, and you would get exactly this original 9x plus 9. Okay? So how do we divide 9x plus 9 by 9? Just like 5.5 that we were just doing.
Would be x plus 1.
Yeah, because how would you do it?
Divide 9 on both terms?
Yeah, divide 9 on both. So this looks like,
9x over 9.
yeah, 9
Plus 9
times.
over 9.
Exactly.
Is that right?
Split it up to both. And so what you end up getting is this original term is equal to 9 times x plus 1. And factoring is another thing that's so easy to double check. Because if I give you a polynomial and say factor, how could you really easily check if you got the right answer?
Plug it back in.
Plug in is more like I'm thinking put a 2 in for an x. Yeah, just multiply them back together, right? When you factor 6 and get 2 times 4, how could you check if you were right? Go 2 times 4 is 8, what? I made a mistake, right? So when I factor this out to 9 times x plus 1, if I want to double check my answer, I just multiply this back in and go 9x plus 9, check, okay, I did factor it right. Okay, so really easy to double check. Yeah.
You want us to show all our work just like that?
I mean, I would say on your first couple, but no, not on every problem. But I would definitely say show all your work on the problems where it starts to get complicated with x's and y squareds and z to the thirds. I would say showing your work would be really helpful. But yeah, eventually it would become second nature and you don't need to show every step. Okay, let's do another example here. Alright, so a problem like 20, which is 32x minus 24, and a problem like 32, which is 12x squared minus 4x to the 4th. And off to the side, I'm just going to talk about the general steps. Okay, so the general steps, 1 is find the GCF. Of all the terms. 2 is write it out front, comma, multiplied. Oops, times. Big parentheses, and 3. And inside the parentheses, divide the original polynomial by the GCF. Okay, so what's the GCF of the first one?
8.
Yeah, so the GCF here is 8. So what I'm going to do is I'm going to first start and say, okay, I've got 8 times some parentheses. Okay, in the parentheses, I'm going to divide out the 8 from my original polynomial. So I had 32x minus 24, and so I'm going to divide the whole thing by 8. Or in other words, divide 8 into each term. So after factoring out the GCF, this looks like 8 times, and what do we get?
4x.
4x
Minus 3.
minus 3. There we go. Alright, that's it, factoring out the GCF. First you find the GCF, you take it out, and what I mean by taking it out is you divide it out of every term. Okay, so here the GCF is,
4x squared.
yeah, so 4 from the numbers, and x squared is from the two x's. So we get 4x squared times parentheses, and inside the parentheses we divide it into each. So I'm going to write it first. 12x squared over 4x squared minus 4x to the fourth over 4x squared. And so what do we get in parentheses?
4x times 3x minus x squared.
So wait. So we have the 4x squared out front, sorry. And then inside, yeah?
3x minus x squared.
Close.
Minus
One little difference there.
maybe just 3.
Yeah, just 3. Anytime you divide something by itself, we get 1. So it cancels out.
Oh,
That's a really common mistake people run into, is when
Oh,
things
because if
cancel
that x
out.
was there, that would become up to 12x.
Yeah, if it was x to the third
Oh,
divided by
okay.
x squared, we'd have 1 left over.
Okay.
But if it was x to the third, we would have had a bigger GCF to start with.
Yes.
Yeah. Okay. Whoops, don't need the equal sign in our answer. There we go. Alright, let's do a couple more examples. Okay, one more example with 3 terms. I'm going to add one little wrinkle to this. So 32x to the fourth plus 2x to the third plus 8x squared. Okay, so first, what is the GCF? Right, so the numbers, first start with the smallest number, logically. That's probably going to be your limiting factor. We'll say 2, the only factor of 2 is 2. So does 2 go into every term? It does. Okay, our GCF has a 2 in it. And then how many x's?
2x squared.
Yeah, exactly. So okay, this is going to be 2x squared times parentheses. And then I divide every single one by 2x squared. Okay, so we get it's 2x squared times, and what do we get in parentheses?
16x squared,
Yeah,
x,
yeah,
and 4.
there we go. And that's how to take out the GCF. Now the one wrinkle I'm going to add to this is if the first term is a negative, I hit it. Okay, so if the first term is a negative, we're going to take out a negative with the GCF. Okay, now in general, greatest common factors are always positive, so this isn't technically taking out a negative GCF, but that's the way we're going to talk about it. So if the lead coefficient is negative, take out a -1. With your GCF. Okay.
What do you mean, what's coefficient mean?
Coefficient is the number next to the lead term. Okay, so we'll do an example real quick of this. The reason why you'll see in chapter 6 is, I think none, or let's just say none, although I think you could actually get by with 1 or 2 of them, but none of our factoring methods work if the lead coefficient is negative. Right, so first off, we have to pull that negative out front, otherwise none of our methods work. And this is one of those things where I say, what's the first step here? And you go take out the GCF altogether, and if you don't do it, anything you do after that is necessarily wrong, because you can't use our methods if there's an extra x in every term. And you can't use our methods if the lead coefficient is negative. So you have to be careful that you take out the GCF correctly first, otherwise the rest of the problem is, if not much harder, possibly impossible. Alright, so let's just do a couple examples of this, just 2 should be enough. Okay, so here's an example, same type of problem as before, the only difference is when we write it in order, So this is correct order, our highest power of x is first, but the lead coefficient's negative, okay? And off to the side, I'll do one more example, 52 here. Again, same thing, negative x to the fourth, plus 9x to the third, plus 6x squared. I purposely chose this one because everything else is positive, right? But the lead coefficient's negative. So to use any of our factoring methods in the entire rest of chapter 6, first we have to take out the GCF and get rid of that negative sign by factoring it out. Okay, so what's our GCF on the first one?
5.
Yeah,
Negative 5.
-5. So the GCF is really 5, but we're gonna take out a negative with it so that the first term is negative. So we have -5 times 15x squared over negative 15x squared over -5 plus 20 over -5. So finally we have whoops, 3x squared, yeah, and then
Minus 4.
-4. Alright. And now that lead coefficient is +1, we're good to go. Well, +3, not +1. Okay, what's the GCF on this one? Okay, so -3
X squared.
and x squared. So -3 being the number, x squared being the variable. So we have -3x squared times something. And then we just do -18x to the fourth, plus 9x to the third, plus 6x squared, each divided by that GCF. And again, this will become such second nature, you won't need to write this step, but it's a great habit to start with, so you can always fall back on it. If you skip the baby steps, you don't have anything to fall back on when things get more difficult. Okay, so that becomes positive 6x squared minus 3x minus 2. Okay, and this is a problem we can absolutely factor with 6.3. This, we can't factor if we don't take out the GCF, we have no method to factor this. This, that's section 6.3, that totally works. Okay, yeah.
Why can't we make like -3x squared positive?
You can, but the problem is, if you don't take out this negative, then the signs would be like this, and then our factoring methods don't work if the lead coefficient is -6, or like clever ways that we're gonna learn in 6.2 and 6.3 to factor trinomials won't work if that lead coefficient is negative. So if you leave it in there and then you try using our methods, you'll either get the opposite of what you should have gotten, or you'll just get nonsense, because your numbers won't add up correctly.
Yeah.
Yeah, because of the negative sign. So that's why we take the negative sign out, is so that we can use these nice clever tricks that mathematicians have developed over centuries and centuries. It's pretty crazy how old this math is. It's been passed down to you from generations and generations. This isn't new stuff. It's pretty amazing to me. Okay. Yep. Okay, so what about factoring out a binomial GCF? Oh yeah, this is where it gets really good. So 58, still just the same thing, x times x plus 7 plus 10 times x plus 7. So how many terms are there here?
There'd be 4.
You'd think there'd be 4 terms. And if we multiply, if we distribute it out, there'd be 4 terms. But right now, there's only 2 terms. This term added to this term. Okay? So what is the GCF of those 2 terms?
X plus 7.
1.
X plus 7.
So I think you guys said it, but it was
1x
a little
squared?
jumbled. So think about it. This term is completely made up of x times this parentheses, and this is made up of 10 times this parentheses.
So they have X plus 7.
Yeah, they have the entire parentheses x plus 7 in common, right? We couldn't take just the 7 or just the x or change it at all to
So
be
we have
x
to put those
times
parentheses
7.
in there too?
Well, yeah, I mean, you don't technically need it, but I mean, just to be clear that it's a
Oh.
group, it comes as a package. You can't take the 7 or the x or change it in any way.
Okay.
That comes as a package. So we could take out the GCF, and we could say, alright, well, so x plus 7 comes out front times what's left over? Well, here's x times x plus 7 over x plus 7, and then plus 10 x plus 7 over x plus 7. So look, cancel that out, and we're left over with x plus 7 times.
X plus 10.
Exactly. So we could factor out any common factor. It might look different. And again, in math, that's such a huge thing. Being able to see it when it's factor out a 4 or 2x squared, and then just making it look a little scarier, but doing the exact same steps with the exact same logic. What's common between this term and this term? Take it out, regardless of whether it's in parentheses or whatever. Okay? Alright, so just to do 2 more examples of that, because that's our stepping stone into our other method here. Okay, and just to be clear, yeah, I'll just say, just notice there were 2 terms there. Okay, not 4, there was x times x plus 7 and 10 times x plus 7. They have x plus 7 in common. Just to be clear, so you make sure you write it and you don't go back confused. Alright, so 60 is factor this. And then 66, a little trickier, is a perfect stepping stone or segue into our last bit of this section. Alright, so for 60, what's the GCF?
Plus 3.
Yeah, there's 1 term here, 1 term here, so the GCF is the entire x plus 3. So we get x plus 3 taken out, and what are we left over with? After we divide x plus 3 out of the first term,
X minus 8.
yeah, divide x plus 3 out of this, we're left with x minus 8. Okay, I didn't show all the steps that time, okay? What about this one? A little bit harder. What's the GCF?
X plus 1.
Whoa, but what? But what is it? I mean, how is it 2x plus 1? There's 3 terms. One of the terms is only 1.
Is an imaginary 1 in the front of the 2x?
Kinda. I mean, the GCF is 2x plus 1 if you look at it a little differently.
The addition basically second.
Exactly. You could think of this addition sign separating a first term with a second term. And you could put in some imaginary parentheses here. Right? And this is the last section we're gonna do. It's called factor by grouping, where you cleverly group your things as you would. Now realistically, because it's beginning algebra, the clever grouping is, I'm gonna write it in order. You're gonna have a very clear signal that is, there are more than 3 terms. So anytime there are 4 terms, you would say, hey, I'm gonna factor by grouping, and the groups will exactly be the first 2 terms in a group and the second 2 terms in a group. As you get to 263, there could be 5 or 6 terms, and you have to cleverly group them, maybe even rearrange them, be like a group of 1 and a group of 2 and maybe a group of 3, and then those 2 groups combine to make this group, and it gets much crazier, more exciting. But right now, we're gonna have 2 groups. First group will be first 2 terms, second group will be second 2. But you add those parentheses and notice the GCF is 2x plus 1. So now we have 2x plus 1 times, in parentheses, oh, here comes another big mistake. If we divide 2x plus 1 out of those, what do we get?
just 5x.
Plus one?
Plus 1, right? Because there's two terms. Think about it this way. If I only have 5x and I distribute this into 5x, I only get this term, right? Where did this one go? Double check your work and it's now disappeared. So anytime you divide something by itself, once we divide out this 2x plus 1, 2x plus 1, here you get 5x, but that is a crucial mistake when we take out the GCF that lots of people will make on this next test. When you take out the GCF and you divide a number by itself, you are left over with 1. The number of terms here will never change. If you factor out a GCF and there were 3 terms, there will still be 3 terms. Never, ever, ever would you factor out a GCF and have the number of terms change or shrink. All right, so this last step. Okay, here it is. It's called factor by grouping. And really, all it is take out the GCF 3 times. Okay, that's all we're really doing. It's just factoring out the GCF 3 times in one problem. But it's a cool factoring method. Okay? Another golden rule here. Okay, so our 2 golden rules so far that we've got from factoring are, our first step is always,
Factor out the GCF.
yeah, factor out the GCF, always. Every time I say factor this polynomial, first things first, factor out the GCF. That never changes, okay? And then our other rule is, after you take out the GCF, the next thing you look at is how many terms are there. If there are 4 terms or more, this is your only method. So your choice is made for you. So first you take out the GCF, then you count how many terms. If there are 4 or more, this is it, okay? In big picture, I think that'll just confuse you, I don't want to say that. Okay, so factor by grouping, example. Factor this by grouping, here we go. So it's going to give you a polynomial with 4 terms. In this case, since it's the first one, it's baby steps. So I know you could combine the 3x and the 5x. Don't do it. Okay, resist the urge. And instead, we're going to cleverly group these into the first 2 and the second 2. Okay, we chose those groups. And here's the important part here. We split this into 2 groups. And here's the important part, separated by addition. Do not, addition. Do not leave a minus sign in between. Okay, here's a really quick reason why over here. If you want to know, oh yeah, why is that? Are you just making things up? Okay, let's look at it. What if we've got 5 minus 2 plus 3? Great, that's 3 plus 3, that's 6. Okay, as soon as you go, oh, I'm just going to group this, that's now 5 minus 5 is 0. Because you can't put a parentheses on the other side between this negative and this 2. Because the negative is attached to it too. As soon as you put the negative outside and there's parentheses, you're now distributing the negative into this 3 that never had a negative, never wanted a negative. So if you want to group this, the very first thing you do is you say this is 5 plus a negative 2 plus 3. And then you can say, okay, now I can group it 5 plus, and then negatives inside. That's totally okay, but never leave a negative in between your two groups. All right. Continuing on the same step, we say, okay, so we've got, oops, too bad, x squared plus 3x plus 5x plus 15. We group this, we group this. Right below that, we say, now we factor the GCF out of both groups. Okay, what's the GCF of the first one?
X,
Yeah, what's the GCF of the second one?
5.
Bam. Okay, so now this becomes 5, whoa, got it backwards, x times x plus 3 plus 5 times x plus 3. You're starting to see what's going to happen here. We cleverly grouped these so that when we took out the GCF, we are left with a common factor. Okay, now, take the binomial GCF out of these two terms. Okay, so as I said, all we're essentially doing with factoring by grouping is taking out the GCF 3 times. We split this into 2 groups. We take the GCF out of this one and this one, that's 2 times. And then all we do is say, oh, but look, now there's an even bigger, cooler GCF that we're going to take out of both of these, which is x plus 3. So taking that out, we get x plus 3, and what's left over? X plus 5. Okay? Let's just do a couple examples and that's where we'll stop. Okay, I'll do an example or 2 with a positive and then I'll do one with a negative. So, let's just do, we'll do one positive and one negative. Okay, 76 is the one with the negative. X to the third plus 6x squared minus 2x minus 12. You notice this time there are no like terms that you could combine. So this really is the only strategy that we have. Even advanced mathematicians, this is the strategy they would all use. Okay. Get to 6.1. Like problem. There we go. Okay, problem 74, which is x to the third minus 3x squared plus 4x minus 12. Okay. So let's factor this by grouping. What are our clever groups going to be?
X cubed minus 3x squared.
Ooh, clever. And?
4x minus 12.
Aha, you saw through the trickery. Okay, what's the GCF here?
X.
Yeah, here it's x squared, the numbers have nothing in common. GCF here is? 4. So we take out that GCF. Plus, we take out this GCF, and we're left with, oh, I see. So now the GCF is?
X minus 3.
X minus 3. And after we take that out, what are we left with?
X squared plus 4.
Awesome. Right? Take out a GCF 3 times. Perfect. Okay, now this one. It's a little trickier. Okay? I mean, I'm going to put my group right here. And I'm going to put my group right here because as I said, they're always going to be in order. I'm not going to try and trick you like that.
it's 6x squared minus 2x minus 12 is the whole group.
I don't know,
Could it be?
I don't know. Could it be? I mean, what do you mean by that?
You said addition splits the groups.
Yeah, so,
So x third is one group, x cubed is one group,
yeah?
and the rest is the other group.
Oh, you mean like split it here? Like that?
Can you do that?
Yeah, we could. Let's see, would that even work? So you take out 2 and you get x squared minus x minus 6. Which you could factor. I don't think that'll help you here. In general, we're gonna do 2 groups of 2. Sometimes, as I said in 263, this will be how you'll do it, and what you'll notice is you'll get something like x to the third minus something to the third, and then we got a cool formula to factor, 2 cubes. And so definitely we could do something like this later. But for now, we're definitely gonna split it with 2 ways, but you're right, we can't do it with subtraction. Right, so you notice that we can't do that, so how can we change it?
Multiply by -1.
Kind of. I mean, you can't multiply by -1 because this is an expression, there's no equal sign. If there was an equals 5, great, multiply the whole thing by -1, awesome. But because there's no equal sign, we can't actually multiply the expression by anything. Could we do?
But plus sign,
And, yeah,
by the -2x,
yeah,
and then a negative right there too.
yeah, exactly. So just change the subtraction to adding a negative, and now you've got one group plus another group. That's totally okay, right? But that negative can't be on the outside, because then you'd be distributing it in, and you would notice down here that there's no GCF. You'd have something like x plus 4 and x minus 4. You'd be like, but there's nothing in common. And the reason is you messed up a negative sign in that first step. Okay, so what's the GCF of the first one?
X squared,
Oh, this is the only.
Okay, what's the GCF of the second one?
2, -2.
Negative, because that first term, anytime the first term is negative, we take out, a negative. So here we have x squared times x plus 6, plus, and over here we have -2 times x plus 6. And oh, look at that, because we were careful with our negatives, we have a GCF is x plus 6, and if we take out our x plus 6, we get times what's left over?
X squared minus 2.
Exactly. Alright, that was good. That was a lot of information. And that's a pretty pivotal start to chapter 6. So there's 20 minutes left. I'm a little bummed we didn't get 6.2, but that was a high quality section. So focus on that work. We got 20 minutes here. I will answer any questions, help you however you want. And then tomorrow we'll start at 6.2.